This place is very special because this is a unique geological object that really highlights the interaction between an old magmatic intrusion and the petroleum system. And overall it gives the key on how magmatic intrusions can control the circulation and the migration of hydrocarbons in sedimentary basins.
The Neuquén Basin really offers an amazing opportunity to look at an active volcanic system, but because of the active tectonics, that gets brought up and eroded very, very quickly in its history. And so we can see things that have happened, at 1-2 kilometers depth, brought up to the surface and inspect them to see what's actually going on in the subsurface.
It could be any fluids. I mean, we have examples, for example, in South Africa, that these intrusions can be important aquifers in desertic areas. But also, if we understand this system, we can also understand how to extract geothermal waters from these intrusions for geothermal energy production.
You can't imagine what it was like having 3 or 4 geologists turn up at, to essentially look at a laccolith, look at an old volcanic centre, and then next minute you've got what looked like Jurassic tar pits. You've got, there was a dead tarantula, there was birds. We even saw, the last time we came, we saw this sheep that had been stuck, or goat that had been stuck there and clearly had perished. Very much like you see the saber-toothed tigers stuck in the tar pits. I mean, it really was an incredible experience, and we were kind of like jumping around with grins on our faces.
Welcome in Argentina. In this video, we will show a spectacular geological example that illustrates how magmatic intrusions can affect the circulation of fluids in the subsurface. This special place is called Cerro Alquitrán. Cerro Alquitrán is a gentle hill located in the southern part of the Mendoza province in Argentina. This hill is actually an old eroded magmatic intrusion that was emplaced few hundred meters at depth. And now it is eroded and it gets at the surface. So what is so special about Cerro Alquitrán? Well, what is interesting, we can see that in the background, there is a lot of bitumen and oil that seeps out from the ground. These bitumen seeps have been discovered in the late 19th century and they have been mined since 1926. Now the mining installations are completely abandoned. We can see the old buildings, some remnants of the installations, but the oil keeps seeping out and seeping out from the ground. So this deposit has been mined for many, many years, showing that there was a lot of oil in the area. And there was so much oil that even several wells have been drilled. Like this one, this is an old well head, and we can see here like a pool, and at the bottom it's full of oil now. But even more interesting, we found oil pits there in the area, just in the background. So here we have actually a natural tar pit with dead animals. So the oil seeps out from the ground. It is liquid, it is viscous, and we can even find a dead goat that drawn into the pits. We find other dead animals, we found birds, insects, we even found a tarantula, so it's really like a modern equivalent of tar pits from the Jurassic. Not only the oil seeps out like as a pit like this, or is extracted from wells, but here the bitumen and the oil seeps out all over and exhibits different features. We can find, for example, solidified oil flows which flowed a bit like a lava flow, and now they are solidified, but they look exactly the same as pi-oil basaltic lava flows. So we have a lot of oil in the area. Like we can see here, the oil seeps out from the ground. But why here? Well, we have actually clear evidence that there is a relationship between the intrusion of Cerro Alquitrán and the seeping of the oil. Indeed, the main seep areas are located near the edge of this intrusion. We also can find some minor seeps at the core of the intrusion. But how does that work? How does the intrusion can control the migration of fluids which are absolutely not related to magmatic activity? To find the answer, we need to look at the magmatic rock itself, and we found the solution, the answer of that question, in a gully on the other side of the Cerro Alquitrán. So go, let's have a look. So in the background here, we see this gully that actually erodes the andesitic body. So we can really see in the interior of what used to be a magmatic intrusion. And also what we can see these black flows of bitumen. And the bitumen seeps out directly from the andesite. How does that work, and how does the andesite control the migration of this bitumen? Well, then we have to look at the rocks there. Let's have a look. Quite crazy. So now we are really in the core of this andesitic magmatic intrusion. And what is striking here is how much fractures there are and how much fractures affect the andesite. You can see these long fractures cross-cutting the entire andesitic body. And also in more detail, we can see that the rock is completely brecciated with lots of blocks, lots of clasts, lots of fractures. And from the fractures and the blocks in the space between the blocks, we can see the bitumen coming out to the Earth's surface.
I think that's what's really striking to me, is that you can literally put your finger on the cracks within the rock where the oil is seeping out. What do you think's caused all of these fractures and cracks?
Yeah, well, that's a good question, but what we did some mapping, and it's clear that we find these fracture bands and these breccia bands near the edge of the intrusion. So our idea is that when the magma was emplacing, it was sheared intensively near the edge, and it was so viscous that it couldn't flow, but it was breaking. So around the edge of the intrusion, we have a high permeability zone related to all this fracturing, all this brecciation, along which the fluids, here the bitumen, can migrate and seep out at the surface. So this is the combination of this fractured magmatic body and these amazing flows of bitumen seeping out of the andesite that makes Cerro Alquitrán a world-class example that shows how fractured magmatic intrusions can completely modify the permeability architecture of sedimentary basins and control the migration of fluids in the subsurface.
Se fue alejando y quedé con tu partida, con los ojos empapados de llorar tu despedida.
Cuando se quiebran los sueños, como un cristal en las manos, son profundas las